Okay, this is it, kids. 7-1. Chapter 7 is a super important chapter. If you don't understand a chapter 7, me oh my kids, have fun. Okay, let's talk about different combinations. Okay, we have three packages of oatmeal. If we write that as a variable, we can say, wow, that's not an O, that's an A. 3O, like oatmeal. How about this one? I got 6, please. How about this one? 3 meats. How about this one? 4 beans. How about this one? 6 corns. And then lastly, how about 4 rice? We can't add these together because they all have different letters next to the what's called coefficients. That number right there is called a coefficient. And a coefficient identifies how many of the variable that you have. So for example, if I said 7x, well, I've got 7 x's. That's an x. And then you add those together. And that's why you have 7 x's. Boop, right there. Okay? Right. Once again, that number right there is called a coefficient. Okay? Oh, it's called a coefficient. Okay, keep that in mind. Okay, whenever we're dealing with one group, right, which is one number and one variable, right, a coefficient and a variable, it's called a monomial. The degree of the monomial identifies, well, what type of degree is it, right? And it's usually the exponent, okay? So for example, this right here. Therefore, the degree of the monomial, the degree is 7 because there's only one of these and you add those degrees together. It's 7, okay? Simple as that. Anything to the power of 0, it becomes 1. That's why it's just 7. So anything to the power of 0, boop, 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 it just becomes 1. It goes bye-bye, essentially. So as we move on, okay, why is this called a cubic binomial? Well, here's the thing. We have two terms right here and right here, okay? We have two terms. Binomial means 2. Cubic because that exponent on top of the x is 3. Bing, bang, boom, we got it, okay? Without an x, constant. 1x, linear. With the 2 on top, the largest degree, quadratic. One term, we add these up, it's cubic though, okay? This right here, 4th degree, because those add up to 4 essentially, okay? Ooh, just like that, okay? Keep that in mind, okay? This right here, monomial, because there's 1. Binomial, because there's 2. Trinomial, 3. Polynomial, because there's more than 3 usually. Okay, here we go. This one's going to be 3rd degree, and this is a monomial. Why? Because there's only one term. There's 3 terms, so that's a trinomial. And this is going to be a 2nd degree. Because there's 2, there's 1 adds to 2. Okay, now we need to write them in standard form. Whenever you write them in standard form, we talk about the largest degree first. The largest degree first. Okay, me and I right there. Okay, let's look at this one here, for example. Okay, that's not the largest one. Actually, this is the largest degree. It's a number on top of the x, so negative 3x cubed plus 6x squared plus 7. Okay, boop, we got it. How about this one? Negative 8y squared plus 2y minus 3, boop, we got it. Let's put the degrees in order. Not the coefficients, the degrees. The number is not on top of the variable. Very important. Now we talk about adding and subtracting like terms, okay? You have the ones that have the same degree on top. So notice this, boop, boop, add those up, 4x squared. Now we do the x's, boop, boop, 6x, okay? And then boop, just 5. Boop, you got it. That's simple, kids. That's simple. So now let's look at these here. X squared, boop, boop, 3x squared. Boop, boop, that's gone. This and this, that cancels to 0. We're done. How about boop, boop, 12y squared. Or, well, not squared, but cubed. Let's erase this. Let's make it cubed. Boop, boop. Now the next one, boop, boop. Negative 5y, boop, boop, and then plus 7. Notice how I don't add degrees. I only add the numbers next to them. That's important, okay? Let's ignore this part. I'd rather just focus on the next example. Because remember, whenever we're adding like terms, it's just combine them. That plus combines with this. So this can't combine with anything on the other side, so 3x squared. Okay, 2x with negative x, that's going to be plus 1x. And then lastly, the 9 is just 9, so plus 9, boop, we're done. Negative 2x squared, nothing, so negative 2x squared, we're done. 5x plus 3x, that's 8x, boop, boop. And then negative 7 plus 7, that's 0, boop, we're done. Here's the kicker with subtracting though, okay? Whenever we subtract two sets of terms, we have to change what these symbols look like, okay? So notice that's negative 3x squared, okay? Negative 5x plus 8. We distribute, then we combine like terms equally. Let's look at this one first, okay? These change and this changes, so 3x squared plus 4x plus 2 plus x minus 4, combine like terms, 3x squared, we're done with that. 5x, we're done with these, and then minus 2, boop, we're done. Okay, lastly, distribute, negative 5x minus 6 minus 4x squared minus 6. We combine like terms, there's nothing with the x squared, so negative 4x squared, boop, we're done. Minus 5x, boop, we're done. And then minus 12, boop, we're done with that. Simple, very simple, okay? Here we go, moving on. Okay, area, all we're doing is combining like terms, blah, 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 simple as that, okay? So let's look at this example. What expression models the difference between the total area of the large solar panels and the total area of the small solar panels, okay? So let's find the difference, large, small, large, small. We're subtracting, okay? So this becomes 28x squared, boop, boop, and then 384x minus 24x, that's plus 360x. Boop, we're done. You got it, you're done. That'll conclude the lesson. It's a very simple lesson. Understand how to combine like terms. Very important for the subtracting one that you distribute first, then combine like terms. Bing, bang, boom, that concludes 7-2.